Good afternoon, everyone. My name is Tom Carey and I'm from the National Nuclear Laboratory. Welcome to the third of 5 webinars that aim to provide background information on the NDA's annual PhD bursary calls. We've already had 2 webinar sessions so far on the topics of land quality and spent fuel nuclear materials. And the presentations for these webinars will be on the NDA website later this week. But the topic we're going to talk about today is in the area of decommissioning. Just a few things before we start. This webinar is now being recorded and will be made available via the NNL website. It's an open forum and the presentations have been cleared for dissemination. Questions can be submitted after the presenters have spoken, either verbally or submitted via the Blue Jeans chat function, and I will read them out at the end. Please note that if there are any questions that deal with sensitive topics, it may not be possible to provide an answer today, but I will make a note of them, these questions, and aim to provide written answers and post them with the webinar on the website. One last thing before I hand over, I'd like to ask everyone to mute their microphones while the presenters are talking. And if everyone's done that, I'd like to hand over now to Rick Short from the NDA, who's going to give a short presentation. Okay, Rick?
Okay, thanks very much. If we can move on to slide 2, I'm just going to give a very quick background as to why the NDA supports PhD research and some of the differences between the research that we support directly through our direct research portfolio and that the SLC support themselves. And then I'm going to hand over to the technical leads, Tina, Alexander from EDF and Tom from Sellafield, to talk about the decommissioning theme call in a bit more detail. And then following that, we'll have a question and answer session at the end. Okay, so we can go on to slide 3. So this is just an outline of the reasons why NDA supports PhD research. So one of our key drivers with funding schemes like the PhD bursary scheme is the maintenance and development of the key technical skills that we're going to need to carry out the NDA's mission over the coming decades. So this is really about making sure that we have people in place, the technical experts in place that we need to lead these projects within our site license companies, but also to make sure that the supply chain has got the expertise that it needs to call upon as well, and making sure that within academia itself there are plenty of people there to teach the future generations of these technical experts. A lot of the work that we do is about providing the fundamental understanding about the processes and the techniques that are used across the estate. A lot of the technology that we've got is adapted from other industries, and sometimes we need to have a bit more of a deeper understanding of the fundamental issues in it to make sure that we're using it in the most efficient and effective ways. And the vast majority of the research that we sponsor at university level is early technology readiness level research, so it's technology readiness levels 1 to 3. And that all feeds into the wider R&D program that's supported by the direct research portfolio, by the site license companies themselves, in feeding into developing this technology into end user readiness levels. And a big part of what we do through the PhD program and the direct research portfolio is encouraging knowledge transfer. And this is one of the reasons why we have an industrial supervisor for each of our PhD students. So that industrial supervisor's role is twofold in terms of knowledge transfer. He's there to make sure that the student's project and the student's academic knowledge is kept up to date. So we're making sure that we're keeping those projects relevant to the needs of the sites. But it's also there to take the learning from academia back into the sites and make sure that learning and that sort of new knowledge is being transferred back into the industry. And so we're being kept abreast of the new developments that are happening at the universities. Okay, if we can go on to slide 4, please. So this slide is just a bit of a demonstration of the difference between the kind of research that we're going to fund through the direct research portfolio and that might be funded by our site license companies. So as I've sort of already said, the direct research portfolio is there to make sure that we can keep all of the skills and capability that we need to undertake the NDA's mission in place over the coming decades. It's there to encourage innovation, to look for opportunities to improve efficiency and the effectiveness of the and the technology we need to employ to do decommissioning. And we also will fund research that can support the strategic decision making. So this might be to provide raw data or even to provide the concepts that feed into that strategic decision making process. And one of the outcomes of this thinking and this philosophy is the PhD bursary call itself. This contrasts slightly with the way that the site license companies go about funding R&D, and the aims of their R&D is generally more about improving the baseline for the site cleanup. And to improve that baseline, they have a couple of sort of primary drivers for academic R&D. One of those is the maintenance of specific capability. So that will be capability that's sort of for operating particular processes or plants on the sites. Or it might be more needs-driven and more plant-specific research that's being undertaken as well, and that's to sort of make processes more efficient or to gain a better understanding of the technologies being used. Okay, so we go on to that last slide, number 5. This is just really, this is a slide that I presented last year as well, and I keep it in because I think it sort of provides a good sort of synopsis of why we fund R&D in the first place. The NDA's mission is a very long time frame mission, stretching out over 100 years according to the current baseline plans, and it's going to cost a lot of money, somewhere in the region of 95 to 200 billion pounds. Any R&D that we can do that improves those numbers, it makes those numbers smaller, is worth doing. That's an awful lot of taxpayers' money that we're planning to spend on the NDA's mission, and we want to make our mission more effective and more efficient to try and reduce that overall cost. And that really is the ultimate aim of funding these R&D projects. Okay, so I'll leave you with that thought, and I'll pass you over to Tina now, who's going to talk about the thing.
Tina, are you there? Okay, if Tina isn't on, would it be possible to move over to Tom's speak talk?
Hello, yeah, that's fine by me. Can you hear me?
Yes, Tom, thank you. What slide do you need? If you want, we can just start from the start. Okay, great. Yep, please.
So I'm going to say this now. Unfortunately, I haven't managed to load the screen up, so I'm not actually sure what slide we're looking at. So I've got it printed off in front of me, and hopefully I'll be able to get onto it as we progress. So apologies for that. If we start with, so we've got the sort of title slide and then research themes and presenters. Are we on that slide?
Yeah, we've skipped ahead for you for the decommissioning working group slide, but I can go back if you want. No,
that's absolutely fine. So all that I'd say on the decommissioning working group is, as I'm sure you're aware, it's supported by all the SLCs and focusing on decommissioning. So we're looking to identify a number of different research themes today and hopefully get some PhD calls to support our themes. So if we go on to the next slide, the problem statement. So a high-level problem statement. Basically, we're trying to focus on a number of plant areas across all the SLCs where we can't actually do manual physical decommissioning work, although I'll come on and later explain how sometimes that is the case in terms of alpha decommissioning. So there's a very high need for remote capability in dismantling and deconstruction to enable our decommissioning mission. And yeah, effectively, we're just trying to get all sites and all SLCs safely decommissioned in as cheap as possible. So focusing on the challenges, so these list some of the high-level challenges. There's different materials and different geometries, as you can see from some of the pictures. Complex plant, minimal space, and access is very restricted. We're looking at existing accesses of penetrations less than 30 centimetres, so there's really not much room to get stuff in and out. And where possible, we'll do manual entries because men tend to be a bit more reliable and a bit more capable than the machines we currently employ. So if we go on to the next slide, DWG research themes. These are the high-level themes that were identified on the website. So they focus in 5 main areas: treatment and recovery of waste, the monitoring decommissioning facilities, decontamination, decommissioning tools and techniques, and treatment of land and buildings. So you can read at your leisure the information through here, and that's all on the website. So if you go onto the website after, you can read these different themes. This is effectively the high-level scopes of what we're trying to do. So if we go on to the next slide, what is decommissioning? What we've got here is a high-level flow diagram of the typical operations used in decommissioning. So obviously the blue circles or oblongs are the decommissioning operations. So this is typically, well, this is supposed to represent all decommissioning schemes for all facilities. So we'll have operations and then a POCO phase, which is post-operative clean-out. In POCO, effectively, you're trying to make the plant as safe and clean as possible while working within the existing safety case that the facility would have during its operational phase. So from there, we'll do some characterization, which is really important to help underpin what our decommissioning schemes will be. And it's also useful to know what it is we're actually trying to decommission. So it's quite an important stage. From then, we'll look at installation and access. So this is particular to individual equipment or facilities. So obviously, you need to prepare the ground before you can decommission. So this stage is just effectively making that ready. Then we'll go on to decontamination. Decontamination is really a continuous process throughout decommissioning. You might want to decontaminate individual waste items or individual areas of plant in order to either fix contamination, so contamination doesn't spread across whole facilities, or you might want to try and reduce the classification of the waste item from intermediate level waste to low level waste, for example. After decontamination, we've got the main crux of decommissioning, which is the dismantling and deplanting stage. Deplanting, you're effectively taking things out the same way you put them in, so unbolting screws and then taking things off walls and that sort of stuff. And dismantling, you'll be using physical aggressive processes like cutting, drilling, sawing, crimping, whatever you can imagine to physically remove items of waste from a facility. Once everything's chopped up into little bits, you'll have to retrieve it, which is pretty self-explanatory process. Then you might do some waste processing. So this might be sort and segregation of different materials so they can go in different waste streams. Or you might want to do some decontamination here again to reduce the level from ILW to LLW, for example. Next we have waste packaging, which is, again, pretty self-explanatory, getting the size-reduced waste into the correct container for either long-term storage or further processing down the line. Typically, plants will have a surveillance and maintenance phase where they're in a sort of safe state, but without actual work ongoing. So this is very common in nuclear reactors, where facilities will be put into surveillance and maintenance phases for tens of years, perhaps, before final decommissioning takes place. So final decommissioning or strip out, it's just the removal of all the remaining waste items that you haven't done in the dismantling and deplanting phase. And then you'll have demolition of the facility and potentially some land remediation, depending on the actual facility itself. So this represents a... hello? I'm not quite sure what to do with that ringing, to be honest. Shall we carry on? Okay, I'm going to carry on. So if we go on to the next slide, where do we need R&D? This is just the research themes, again, taken from the website, just the 5 main themes. So looking back at the decommissioning scheme that we just had up, we've got things like recovery and treatment of waste materials, monitoring, decontamination, decommissioning tools and techniques, and treatment of contaminated lands and buildings. So really, our research themes are covering all aspects of decommissioning. And if we go on to the next slide, this will make it extremely explicit. The fact that you've got everything covered, whether it's through different working groups like in characterization and waste packaging, or if it's covered by our decommissioning teams. So decontamination, dismantling, waste recovery, waste processing, and surveillance and maintenance. And then the other themes, the other steps on the flow sheet are either equipment or location specific. So it's not particularly appropriate to have a research theme in perhaps like installation of equipment, because obviously it depends on what your equipment is. So that will be wrapped up in some of the other work ongoing. And also strip out is where we just typically use standard techniques. So that's either manual work or just using commercial off-the-shelf COTS equipment. So if we can go on to the next slide. So decommissioning at Sellafield. Obviously, I'm a Sellafield employee, so I'm going to focus my main discussion on Sellafield. But that's perhaps appropriate because it is the largest decommissioning challenge in the NDA estate. It's estimated to cost at £24 billion to decommission Sellafield site, with the rest of the sort of lifetime cost being in waste retrievals from legacy ponds and silos, and also waste storage and processing. So it's quite a big market. £24 billion is a lot of money, and we think with R&D we can knock a significant amount of money off that and, you know, make it a lot cheaper for the taxpayer. So Sellafield itself is a reprocessing plant at the moment, but this will stop in 2020, where both Thorpe and Magnox repro will have ceased, and Sellafield will become just a decommissioning site where we've entered broad front decommissioning. So when we think about decommissioning, especially at Sellafield, it's convenient to split it into 2 areas, alpha decommissioning and beta gamma decommissioning. This is basically due to the nature of the radioactivity, so the actual inherent physics of the way alpha and beta gamma works. Alpha you can shield very easily, so we typically do alpha decommissioning with manual access, so actual men will do the decommissioning, men and women will do the decommissioning.
I am no Dioden, albeit a bit late.
Hello. And no bother. And the other stage of decommissioning, beta gamma decommissioning. This is where man access isn't possible. So we're looking at having remote machinery to do the decommissioning for us. So if we'll go on to the next slide, this is a typical alpha facility at Sellafield. Alpha facilities at Sellafield are characterised by glove boxes. So basically we have series and series of glove boxes where you might do fuel manipulation or processing, you might do some lab experiments or just some general experiments. So the glove boxes are typically contaminated with plutonium or uranium or that sort of stuff. So decommissioning, you can do it in a manual process. When we look at decommissioning as a whole for these alpha plants, the amount of suit entries that are planned it's a lot. We're talking millions of suit entries here over the lifetime of Sellafield. So that's a person getting suited up, going into the workplace to then do this aggressive tasks. So really, if we're looking at that many numbers, statistically, you're starting to enter into realms where you can't guarantee safe operations for that amount of suited entries. So really, we need to either look at new ways of doing alpha decommissioning or improving the safety of alpha decommissioning so that we can eliminate the risk of these accidents, and also just make it easier on operators so that they can complete the tasks, safely and confidently and comfortably within their own capabilities. As we'll have millions of suit entries, secondary waste generation in in alpha decommissioning is quite a problem that we need to overcome. Secondary waste in certain facilities can be up to 12 times the amount of original waste volume. So, for instance, in this photograph, if you were to size reduce all the material there into one big block, the secondary waste generated from tools, suits, gloves, boots might be 12 times that volume. So this is something that we really need to improve. The main challenge when we come to alpha decommissioning isn't the radiation, but more it's the contamination. So rather than focusing on shielding of the radiation sources, what we'll do is try to contain it, which is obviously difficulty when you're trying to decommission a glove box, because the glove box itself is the containment for the radioactive material. So to cut into it, you're actually breaking containment to do the decommissioning. So we need to think a bit cleverly about how we can manage that and to create an optimal scheme. Perhaps there's some way of decontaminating glove boxes beforehand. You might want to apply fixatives within the glove box so all the contamination is contained when you cut it. Whether this is possible or not is still an open research question. So there's plenty on that aspect. And then, you have to think of maybe creative ways of how you can challenge decommissioning glove boxes. Can you manage them whole? So perhaps remove the glove box in one piece and take it to a dedicated facility. We're doing that in some of our facilities on Sellafield site, but it's not really appropriate for all glove boxes because, some are meters tall, sort of the size of large rooms, not just sort of a little glove box that you can decommission. So how can you sort of think differently to actually maximize your decommissioning scheme? So if we go on to the next slide, here's typically a few images that you might find in a normal alpha decommissioning environment. So the first thing you'll notice is it's all manually done. People in air-fed suits with numbers of different layers. When you think about actual processing time, by the time you've got these people dressed up, suited up, and then given their pre-job brief, getting to the work phase, because you might actually have to walk through a large facility, so walk through a number of rooms, managing your air supply cable behind you. So it's not as simple as just getting there and cracking on. Typically, you might get 2 or 3 hours work from each person per shift. So we're looking at a maximum of about, if you're doing 2 shifts a day with 2 people on each shift, you're looking at about 12 hours maximum useful work you can get from a 4-man team. So we need to maximize this, maximize what they can do when they're actually at the decommissioning work phase. So you might want to give them better tools so it's easier to do the decommissioning. Perhaps you can have intelligent tools where the tools themselves do some of the work. So a man or woman can go on and do another job while the tool's actually doing the decommissioning work. So you can set it up. Maybe it will start decommissioning the glove box. You can go away and do some waste packaging or something and then come back and the glove box is size reduced. So maybe this is something that we can do. I sort of mentioned briefly about the risk that there is to just safe operations. You can see in some of the photos operators using grinders, plasma cutters, doing physical tasks like erecting scaffolding. These are dangerous tasks. So how can we ensure that we can do them in a safe way? Maybe we need to think about semi-remote tools where an operator can control a tool removed from the work face. So it might be something as simple as a door on a long pole, but that's not really feasible. So how can we actually take the man away from the dangerous working environment to make it safer for them? Again, access constraints are very pronounced. You've got tight environments. You can see in the top left picture, for example, how they're having to sort of work around existing infrastructure, how there's manual building of scaffolding to get to higher places in facilities. Is there a way that we can somehow improve access for manual operations? So it's a simple process where you can get to the workplace quicker and then you can get on and do your work. So what we're looking for really in terms of alpha decommissioning, we're looking for intelligent tools, some way of reducing the risk of the man at the hazard. We're looking for ways that we can help operators out, whether that be through enhancing their own capability or providing better protection or monitoring of their behaviour and work in the environment. So perhaps this could be something as simple as better communication or systems that can give them live update of the dose they're receiving, so they know when they're reaching their dose limit, so they can work safely within that. Potentially decontamination methods, whether that be fixatives, new chemicals, deployment methods. How can you actually deploy decontaminants within a glove box to the right place at the right time? And maybe we're looking at systems that actually replace the man. So fully remote systems that can either work in collaboration with the man at the workplace, things like collaborative robots, or things that are just totally remote systems where a man can set it up and then go to a safe distance and watch it do its job for the person effectively. Okay, so if we go on to the next slide, it's beta gamma decommissioning. So here we'll focus on cells that have too high radiation levels to actually allow man access. There are certain cases where some upfront work might allow man access, which could be beneficial considering the capabilities that a man has. But then if you're looking at doing that, you can target certain areas. So, for instance, there might be heels and residues in certain vessels or certain pipework that if you can find out where this pipework is, remove it, and then treat that, then the whole classification and radiation levels of the cell will be reduced. So that will give you a much simpler solution. But when you're looking at these pictures of these facilities, that's not an easy task. I mean, how do you identify where the heels are and the residues are in facilities that have got thousands and thousands of meters of pipework? I mean, just for an example, Thorpe has 307 kilometers of pipework in this one facility. I can't quite comprehend how far that is, but 307 kilometers is probably London to Manchester. So, we're talking about a lot of pipework that needs to be decommissioned. How do you approach that? How can you identify in that length the 1 or 2 meters that have got the heels and residues in there? If you remove that, you can, make it a much easier decommissioning scheme. And then if you do identify it, how do you actually deploy something to get to that specific bit of pipework? I mean, you're talking about cells that are tens of meters tall, tens of meters wide. The pipework, like I say, you can see from the pictures, it's so congested. How do you have a deployment system that has the reach to get to these pipework in difficult places, but also the dexterity and flexibility to navigate through these congested pipework? I mean, it's something that we don't really have a solution for at the moment. So if that's something you think you've got an idea of or an idea for, then definitely put in a submission, because it's something that I definitely support. So I don't know about everyone else, but that's definitely one of the top priorities when we're looking at beta gamma decommissioning. So again, we're looking at huge cells, and access is very restricted. Like I said before, existing penetrations can be less than 30 centimeters in diameter. So we're trying to find solutions that can go through small penetrations and cope with massive volumes of waste and massive volumes of structural material to decommission. Okay, so if we can go on to the next slide, please. So here are just a couple of illustrations of, well, beta gamma decommissioning. What we typically have done in the past is either use COTS manipulators, like in the top left, we've got a block demolition machine. These are great. They're really robust machines, but they're not very precise. They're not very dexterous. So if you're trying to deal with cells that have hundreds and hundreds of pipes in, and you want to cut out the second pipe from the left, can you actually do that with such a rugged machine, a hydraulically operated machine? So the next one along is the decommissioning module from the cesium extraction plant decommissioning. This was a highly bespoke system that was designed and commissioned and built by Sellafield. It did the job very well, but it was designed specifically for one purpose, and that was to decommission the cesium extraction plant. So we've gone to all this trouble and all this expense of developing this bespoke machine, but it's only going to be decommissioning one plant. So are we going to do that for every single plant that we have on site? I think that's highly unlikely, considering there's 170 nuclear facilities that we've got to decommission. So how can we create solutions that are specific enough to actually handle the unique aspects of individual plants, but also be flexible enough so we can use them on a number of different plants? So that might be the design of the hardware, or it might be software stuff. You might have intelligent control. You might have maybe a degree of autonomy to the system, so it can deal with unexpected arisings. To be honest, this is something that we're going to have to sort of look at in great detail, whether it is feasible to carry on doing these bespoke deployments for each individual facility, or whether we can have a more general, generic solution for all decommissioning plants. Another thing about the cesium extraction plant, obviously it's highly bespoke, so that was expensive to get it to operate. We had a lot of work up front making sure it could cope with the high radiation environment that we would be working in. So it was designed to a very high standard to allow operations in these high radiation facilities. One thing that we might consider is, rather than doing all that work up front and then potentially having failures due to maintenance issues or just general wear and tear of the machinery, what about disposable solutions? So we can use something for maybe 2 months and then it reaches the end of its natural life and we dispose of it as waste. But in that process, the whole system is so cheap that it doesn't actually matter that we're only using it for a short length of time. So we can use maybe 10, 20 machines to complete this one job, which will be cheaper than doing one highly bespoke, sort of all singing, all dancing solution. On the right, the facility, there's a picture of a a schematic of a facility that actually uses 4 different manipulators to decommission the one cell. So one of the actual manipulators is repeated in the zone 2, I think that says, or zone E. Sorry, I'm going from the print off. I can't quite read it. But yeah, we're looking at 5 different manipulator deployments to decommission one cell. Surely there's a better way of doing that. Surely we can have one deployment to decommission one cell. We'll have to think about how we can actually make access to deploy these systems, what the capabilities of these systems are, and how we actually manage decommissioning within the environment. So you've got things like a crane deploying a manipulator from the top. Can we not deploy a long arm reach manipulator from a crane? Or can we not develop a system that actually can encompass the whole of the facility in one decommissioning deployment? Okay. So obviously deployment is one big issue with a decommissioning beta gamma facility, but you're not actually going to decommission a facility by just deploying it. You need to do work. You need to have tools and techniques to actually decommission, deplan, cut and remove things. So these are could be simple solutions like saws, but when you're looking at saws in a remote environment, they're so slow to operate. How can we sort of bring the next generation of decommissioning tool along? So in the bottom left, we've got a picture of the laser snake system that we trialled at Sellafield this summer. That used a laser cutting head from the Welding Institute to actually do laser cutting of, in this case, a dissolver vessel in the environment. So obviously the laser had a lot of benefits over traditional techniques. It was a lot quicker to actually do the actual cutting. There were no wearable parts, so it can theoretically work for a lot longer than a conventional saw. And also the standoff distance is variable, so we can actually have less precise control methods to do the decommissioning operation compared to traditional things like saws and drills and that sort of stuff. So lasers are just one example of a next generation decommissioning tool, but I'm certain that there's hundreds and hundreds of tools out there that can be either adapted or brought from different industries to the nuclear industry that we can deploy straight away and see a massive benefit and an improvement in productivity for our decommissioning operations. So all in all, when we're looking at beta gamma decommissioning, what we're trying to find is things that aid deployment. So how do we get the tool, or whether it's for cutting, for decontamination, for characterization, so sensors, how do we get those tools to the workface and actually do the work that they need to do in decommissioning? And then what are the tools themselves? How can we actually improve the decommissioning scheme by having next generation tools that can do the job a lot better? We also might think about control. At the moment, we have one man operating one machine at one time. Why don't we have 3 machines in there controlled by one operator, and perhaps introduce a bit of autonomy to the machines so they can do some of the work themselves, or have sort of automated processes or intelligent control where we're not actually relying on a man driving a joystick to do the work, but he can set the job up and then it can actually go and do the decommissioning for him. So if we go on to the next slide, just want to give a bit about Sellafield and our technology deployment before I finish up. So obviously here we're looking at bursaries, the NDA bursary scheme and PhDs. And what we typically expect from an output from a PhD is just some low-level research. We're not expecting a solution that can go straight into plant and do the decommissioning, rather proof of concept or proof of principle that we can then carry on the development process either with yourselves and Sellafield, or sort of take that learning and then go on to work with SMEs or members of the supply chain that can then bring whatever is produced from your PhDs up to market and to be deployed at Sellafield. So we've also got a thing called Innovus, which is trying to achieve this aim. It's an external funding body from Sellafield that we support that gives funding to produce proof of concepts or working prototypes. And it's just sort of seed corn funding that will help you support the development of a product, in effect. So if you're interested, I'd highly recommend going on the Innovus website. They've got a lot of information about Nuclear Challenge, as well as a lot of support, both in terms of business support and technical support to help you get into the nuclear decommissioning market. So where I sit within Sellafield is I sit in the technical directorate, which we typically have a long-term view for our R&D. So we're looking to impact technology, sort of promote technologies that impact over a 5 to 10 year time period. When we consider the decommissioning kind of plans for Sellafield, a lot of the work, particularly in beta gamma decommissioning, kicks off in around 2025, 2030. So if we're looking at a 5 to 10 year window, we've got, we're going to impact when the plants come online for decommissioning if we focus on that sort of time period. So we're developing these things called integrated project teams, which are looking to sort of focus our own research in various areas and that'll be coming online in the next year or so, and it will also help to focus the challenge even further so we can communicate out what it is we're requiring. Future decommissioning are responsible for active demonstrators at Sellafield, and this is something that you might consider when you're getting to the latter stages of your PhD and actually producing usable output. What we can do is we can take your technology and do a demonstration at Sellafield in an actual nuclear facility. So these are facilities that need decommissioning, but are actually low on the priority level. So they are a proper nuclear facility, but because of the sort of low risk and effect of the facilities, they're not on any critical path. So we can use these facilities as sort of lead and learn examples of how to do decommissioning. So if you do have usable outputs from your PhD, and you want to do an active demonstration, that's definitely something that we can look at doing. And then obviously the final stage is decommissioning deployment, where we will do decommissioning in anger. So if we go on to the last slide, I'd just like to thank you for your time, and obviously we've got the next 20 minutes or so to answer any questions. So I'm not quite sure how this whole process works. Rick, can I sort of hand over to you, or how do we go on from here?
Yeah, thanks, Tom. We'll pass it back to NNL, and they'll manage any questions that have come in via the text function on the BlueJean software. Of course, if anybody's got any questions they'd like to ask over the phone, you can do it that way too.
Thank you, Rick, and thank you, Tom. I believe we've got Tina on the line. Is there anything you want to add, Tina, at all at this stage?
No, nothing to add. Just apologies for dialing in late. Had a bit of an issue with my dial-in, but no, Tom did a wonderful job there.
Okay, great.
Thank you.
Are there any questions at this stage?
If anyone has joined us on the phone and they want to ask a question, you can unmute yourself by pressing the star and then 4. Otherwise, you can use the chat function.
Tina, it's Rick here. I just wondered if maybe while we're waiting, are there any sort of, Tom talked a lot about the challenges on the Sellafield site. Are there any challenges that you think may be less apparent on the Sellafield site at the moment, but ones that you're expecting to come forward when EDF go into that decommissioning phase?
I mean, certainly I would say that Sellafield has more issues than we expect to have on our sites. But I mean, we do believe that anything that is developed for access may well be able to be used on our sites as well. We don't at the moment, we don't envisage that we will have the same level of challenge that they have at Sellafield, but we do hope that with the developments that are going forward, there will be, because it's all about, as you know, it's all about a LARP. It's all about doing it the smarter, quicker way. So I can't think of any actual challenges that we would have that would differ. We're just hoping that the work on the more the bigger challenges at Sellafield will also help us at EDF.
Thank you.
Have any questions come through, Lindsay?
We've had one question, but I'm not sure who it's from, so they're going to speak now. From Sufi. Sufi's just getting herself ready to ask verbally, I think.
Just while we've got this pause, I realise that some of you might have questions next week or next month or next year. If you want to get in touch, we've got sort of generic email addresses at Sellafield that you can get through to myself and my entire team. So if you do have questions later in the day, you can email technical.innovation@sellafieldsites.com, and we'll happily answer any questions that you might have.
Okay, we've got one question coming in at the moment. I'll read it out in a second once I've received it. I'd just like to mention that the deadline for the proposal needs to be in by 21st of October. And we've also got 2 more webinars coming up soon. One on waste package storage on the 15th of September, and the final one on characterisation on the 21st of September. Okay, so we've got a question here. In these decommissioning tasks, is there any special environment safety measure, such as oil surrounding environments, that you need to have any systems spark-proof similar to that?
Sorry, could you just repeat that, please?
So the question's asking, are there any environments, this decommissioning tasks, that involve special safety measures, such as scenarios where you've got oil surrounded environments and need to be spark proofed?
I'm sure there are. To be honest, from the top of my head, I couldn't possibly tell you that. But yeah, it's something I can take away.
It's certainly something we would worry about in any kind of dismantling is the chance of a fire. So if you had some way that, I don't know whether that's what's meant. There will be pipe work, etc. that could have flammable liquid or oil or something in it. Maybe. I think that's what they mean, Tom.
I've been here from Magnox, and certainly just from a Magnox perspective, in terms of some of our decommissioning projects, we would consider the use of things like ATEX rated equipment for sparking of atmospheres where there might be increased percentages of hydrogen and things. So there are certainly considerations dependent on the waste storage and the potential generation for hydrogen off some, let's say, fuel element debris, fed bolts, those types of activities, or sludge or anything like that where you might get a generation of hydrogen. You would certainly look to use and consider the requirement for equipment that was ATEX rated to make sure that you don't get any sparking issues.
So that question previously was from Mustafa Sufi Erden from Heriot-Watt University in Edinburgh, and she's followed on and asked, for example, that the machines might need to be built out of special material which is resistant to radiation. I think what. Okay. Sorry, carry on.
Yeah. So in terms of the actual material of the machines, there will be certain things that we look for, and I don't know them off the top of my head, but we do have a lot of sort of specifications that you have to live up to. What I'd say is, at this stage, with PhD research, I wouldn't particularly focus on that unless you were developing something like a new, like a decontamination type method where. So what we typically do to keep contamination off our machines is just kind of wrap them in plastics. So that way we can remove the plastics at the end, and hopefully the machine underneath will be clean. That doesn't always happen in practice, but it's certainly something that we do to reduce and manage contamination levels. So if you're thinking about that sort of stuff, then yes, certainly material choice is very important. But in terms of your actual machine, I wouldn't think it was too much of an issue, just so long as the materials you use can cope with radiation a certain degree. So you wouldn't want to use, well, certain plastics and that sort of stuff, or natural materials are quite difficult as well. I hope that helps.
Okay, thank you, Tom. Mustafa says thank you very much. It's appreciated. Are there any other questions at this stage? If that's everything, I'll draw this webinar to a close. I'd just like to thank the speakers today, and hopefully you'll be at the next webinars. Okay, thank you.
Yeah, and just before we go, can I encourage everyone to submit as many ideas as they have, because even if they're not picked up by the NDA bursary scheme, Sellafield and I'm sure all the other SLCs will be very keen to hear your thoughts. And like I say, we do have a number of other routes that we can go down. So if it's not appropriate for the NDA bursary scheme, submit your ideas anyway. They'll come through to us, and maybe we can pick them up through some of our other work streams. So I just recommend you to submit as many ideas as you can.
Okay, thank you, Tom. Okay, I'll draw to a close now. Bye, everyone.
Thank you.